Okay, picture this. You're on a massive 200-ton airliner, and it's descending through this thick, soupy blanket of clouds. The pilots can't see a single thing outside the cockpit window. And yet, just moments later, you feel that gentle bump as the wheels touch down perfectly on the center line of a runway they only saw seconds before. It feels like magic, right? But it's not. It's actually one of the most incredible, carefully planned achievements in all of aviation. So, how in the world do they do it?
I mean, it's the question every single one of us has probably asked, right? You're staring out the window into the solid wall of gray, and you can't help but think, how on earth do they even know where the runway is? Well, I can promise you it's not guesswork. It's a meticulously designed system of procedures and technology working in perfect harmony. So the secret sauce here is something called an instrument approach procedure. And honestly, the best way to think about it is as an invisible highway in the sky. It's this predefined three-dimensional path with super precise routes, altitudes, and speeds that literally guides the aircraft from way up high all the way down safely to the runway. But before a plane can even get on that highway, especially when bad weather is causing a traffic jam, it often has to wait its turn. And, since there are no parking spots up at 10,000 feet, air traffic control has a clever solution. They send them to the sky's waiting room. This waiting room is called a holding pattern. And really, it's just a designated racetrack in the sky, flown around a single navigation point. It lets air traffic control manage the flow of planes in this incredibly orderly way. Think of it like a temporary parking lot in the clouds. Now, getting into this pattern isn't random. Pilots don't just wander in. There are actually three standard, predefined ways to enter the hold: parallel, offset, and direct. And the one they use is based entirely on the direction they're coming from. It's a beautifully simple system for a really complex traffic problem.
And here's the key to making it all safe. You can have multiple airplanes in the exact same holding pattern at the same time because they are stacked vertically. Each plane is separated by at least 1,000 feet of altitude. So as the plane at the bottom of the stack gets cleared for its approach, everyone else just steps down 1,000 feet, moving one spot closer in the queue.
All right, our turn has come. Air traffic control has just given our flight the green light to leave the holding pattern. Now the journey down that invisible highway to the runway can finally begin. And this isn't just one long slide down. Oh no, it's a carefully managed 5-step process. So the approach itself is broken down into 5 distinct parts. First up is the arrival, which is just leaving the main air route. Then comes the initial segment, where they start maneuvering to get pointed in the right general direction. During the intermediate part, pilots slow things down, get the flaps out, drop the landing gear. Then you have the final segment. That's the last critical descent to the runway. And that fifth one, the missed approach, well, that's the super important escape plan. And trust me, we'll come back to that. But here's the thing. Just like the highways on the ground, not all these invisible routes in the sky are built the same. They basically fall into 2 main categories. And it all depends on the kind of guidance they give the pilots. The big difference here really comes down to guidance. A precision approach is like flying through a perfect 3D tunnel. It gives the autopilot both horizontal guidance, left and right, and precise vertical guidance, up and down. A non-precision approach, on the other hand, only gives you that left and right course information. The pilots have to manage the descent themselves, kind of stepping down in altitude at specific points along the way. Now, when it comes to precision landings, the absolute gold standard, the system used at pretty much every major airport in the world, is the Instrument Landing System, or ILS. It uses these dedicated radio beams sent up from the ground to create that perfect, stable path for the plane to just lock onto and follow all the way down. And get this, the ILS itself has different levels of accuracy that are just, frankly, mind-blowing. A standard Cat 1 approach lets pilots get down to about 200 feet above the ground before they need to see the runway. But a full Cat 3 system, which needs specially certified planes, pilots, and airports, allows for landings with literally zero visibility. The plane can find the runway and land itself completely blind. It's incredible. So what about those non-precision approaches? Well, to make them safer and more stable, pilots today often use a technique called a continuous descent final approach. Basically, they get the flight computer to create its own smooth, constant glide path, which mimics a precision approach and gets rid of those clunky step-down altitude changes. Okay, so our plane is now on that final approach segment. It's slicing through the clouds, perfectly on track. We have now reached the most critical point of the entire flight. This is it, the moment of truth.
where a final, crucial decision has to be made. Every single instrument approach has a decision point built into it, and it's defined by altitude. For a precision approach, we call it the decision altitude, or DA. For a non-precision one, it's the minimum descent altitude, or MDA. This is the absolute lowest the pilot is allowed to go using only their instruments. It's the final gate. When the airplane reaches that exact predetermined altitude, the pilot looks up from the screens and has to answer one simple, non-negotiable question. Do I see enough of the runway environment to land this plane safely? And there are only two possible answers. If the answer is yes, they can see the runway lights, they can see the runway itself, they'll click off the autopilot and land the plane by hand. But if the answer is no, there is zero hesitation. They must immediately execute a go-around. This is that fifth segment we talked about earlier. And let me be clear, a missed approach is not some kind of emergency plan B. It is a fundamental, pre-planned part of every single instrument procedure. It's a published escape route that tells the pilot exactly what to do, what direction to turn, what altitude to climb to get safely away from the ground and set up for another try. And that's why hearing the engines suddenly roar back to life as the plane climbs away isn't a sign of failure. It's the exact opposite. It is a demonstration of a professional pilot and a robust system working together perfectly to make sure that safety is always, always the #1 priority. You know, when you put it all together, it's just such an elegant system. From those orderly queues in the sky's waiting rooms, to the precise guidance of the invisible highways, all the way to the built-in safety net of the escape routes. Every single piece is designed for one thing and one thing only: absolute safety. So the next time you're on a flight and you start descending through the clouds and can't see a thing, you'll know exactly what's happening up in the cockpit. The pilots aren't flying blind. They're navigating a precise, invisible highway. And now you can ask yourself, what kind of highway are we on today?